So piecewise functions are another type of functions, and what's different about them is that we graph them in pieces. That's why it's called piecewise. We graph one piece at a time, okay? So this example right here, f of x equals x plus 3 if x is less than negative 2, but f of x equals negative 2x minus 3 if x is greater than or equal to negative 2. So in other words, they're saying, hey, as long as your x values are below negative 2, use this equation up here. But if your x values are greater than or equal to negative 2, then you use this equation right here. So they're having us graph two functions at the same time. They're having us graph x plus 3, and they're also having us graph negative 2x minus 3, but this one only exists when your x value is below negative 2. So here's negative 2. So when x values are below negative 2, we're graphing this part. When x values are greater than or equal to negative 2, so over on the right-hand side of the graph, then we graph this part right here. So what I like to do is I like to label the parts of my function. There's part A, there's part B. And I like to make a table of values for part A and a table of values for part B, and then I can plot the different points that belong to each piece, and I can put it together on one graph. Okay? All right, so they're saying y equals x plus 3 when x is less than negative 2, when x is smaller than negative 2. So I can only use x values that are smaller than negative 2. So that would be like negative 5, negative 4, negative 3. And I'm going to go ahead and put negative 2, but I'm going to put a little star by that. And I'll tell you why I'm doing that in just a second. Okay, so if x is negative 5, we plug it into this top part, into part A, because negative 5 is less than negative 2. So if we put in negative 5 for x, negative 5 plus 3 is negative 2. If I plug in negative 4 plus 3 is negative 1. If I plug in negative 3 plus 3 is 0. If I plug in negative 2 plus 3 is 1. Okay? So these are points that this graph should go through. So I'm going to go through negative 5, negative 2, negative 4, negative 1, negative 3, 0, and then at negative 2, negative 1, I put a little star by that one. Okay? Notice how when x is negative 2, if you're plugging in a negative 2 for x, you actually have to switch over to part B, okay? Because that one has the equal to sign. So when x is negative 2, I plug it into part B. But I need to put a little hollow dot for it in part A. So negative 2, 1 would be right here, and I'm going to put a hollow dot, not a solid dot, but a hollow dot. And that shows that this part of the graph goes all the way up until you get just barely to negative 2. As soon as you get to negative 2, you have to switch over to part B. But that's a way of showing people that it gets right up next to it. Okay, so I'm going to connect those dots. Okay, and then I'm going to transition over to part B. Notice part B starts when x is greater than or equal to negative 2. So it starts at negative 2. And then I can go to all the x's that are greater than negative 2. So what are numbers that are bigger than negative 2? Well, negative 1, 0, 1, 2, etc. Okay? All right, and I can plug in negative 2 for x and see what comes out for y. All right, so you can do it by hand or you can type it in. Negative 2 times negative 2 minus 3. In other words, I'm typing this equation, but everywhere there's an x, I'm putting in negative 2. That comes out to 1. If I plug in negative 1, negative 2 times negative 1 minus 3, that's a negative 1. If I plug in a 0, negative 2 times 0 minus 3 is negative 3. Negative 2 times 1 minus 3 is negative 5. Negative 2 times 2 minus 3 is negative 7, and so on. And these are the ordered pairs that are part of part B. So negative 2, 1, negative 1, negative 1, 0, negative 3, 1, negative 5, 2, negative 7. And this line is my part B. Okay? Now notice part A and part B shared a point. So even though in part A, my red line here, that was hollow, part B went through that same point and filled it in. So that point ended up getting colored in anyway, but sometimes it doesn't work out like that, okay? All right, so what this graph is saying is, hey, there's one equation for the left-hand part and a separate equation for the right-hand part. But combined, when we group them together, it makes the whole graph. Okay, number 11, same idea. It has three parts. Part A, part B, and part C. And I'm going to make three separate tables. I'm going to have a table for part A. And what numbers go in here? Well, it's saying, hey, use part A when your x's are between -3 and 0. So all the numbers between -3 and 0. -3, -2, -1, and 0. Those are the x values that you should use part A for. Now notice it did not have an equal sign at 0. It had an equal sign at -3, but not at 0. So I'm going to put a little star next to the 0. That's my reminder that when I graph that point, I need to put a hollow dot. Okay, now when I plug in -3, 2 times -3 is -6, plus 5 is -1. And you could type that in your calculator if you needed to. 2 times -3 plus 5, that comes out to be -1. 2 times -2 plus 5, that is +1. 2 times -1 plus 5 is 3. 2 times 0 plus 5 is 5. Okay, so these are the dots that I'm going to graph for part A. So -3, -1, -2, 1, -1, 3, and 0, 5. Remember, 0, 5 is going to be a hollow dot because it gets close to 0, but when you actually get to 0, you have to switch over to part B. Okay, but and I'm going to connect these dots. Now, I'm not extending that line forever. I extended the lines forever on number 10 here because it just said x is less than -2. That means it goes over to -infinity. This one said x is greater than -2. That means it goes on to infinity. It did not indicate that it goes to infinity. It indicated that it stopped at -3. So only between -3 and 0 should I draw part A. Okay, then I switch over to part B. Part B, I'm going to make a table of values. And the only x number they're having me plug in is 0. That's the only x value that x could be for part B is 0. And when you put in 0 for x, notice there's not an x. There's not a place to put that 0. So it's just going to be the y value of 3. So the point 0, 3 is the only part that's graphed for part B. And then we'll make our table of values for part C. And they are saying x can be greater than 0. So I'm going to put a 0, but I'm going to put a little star by it because technically it says greater than 0. So at 0, we're still on part B. But when zeros are cut off, so I'm going to transition over to part C. And I'm going to put 2 or 3 numbers in there. Okay? When we plug in 0 into this equation, -0 is still 0. When we plug in a 1, we'll have -1. Plug in a 2, you'll get a y value of -2. Plug in a 3, you get a y value of -3. So 0, 0 is on this graph, but it's going to be a hollow dot. Then 1, -1, 2, -2, 3, -3. And this says x is greater than 0. That means it could keep going beyond forever. So I'm going to draw an arrow on the right end. The right end has an arrow. The left end did not because they told it to stop at 3. Now I would point out this is a function because it passes my vertical line test. If I drag my pencil across, I never touch more than one point at a time. And some people say, yeah, you don't look. There's 3 of them right there on top of each other. Actually, no, there's only one dot there because this one's hollow and this one's hollow. So this is the only dot that actually exists when x is 0. Okay, at the bottom they say evaluate piecewise functions. Find f of -3. Well, when they say find f of -3, they're saying put 3 in for x. Well, put it in for x where? Well, this function was f of x, this function was g of x. Since they're telling us to use f, we should plug it into this equation. And they're telling us to plug in -3. So we need to decide if -3 should go into part A or part B. Well, -3, is -3 less than -2 or or greater than or equal to negative 2. Oh, negative 3 is less than negative 2. So that means we're going to use part A. We're going to plug negative 3 into part A. If I put negative 3 in for x in part A, I'd get negative 3 plus 3, which is 0. And notice on your part A table, negative 3, 0 was a point. So that's why that y value is 0. Okay? All right, then they want f of 0. So we're still using function f. We're going to plug in 0 for x. We just have to decide if it goes in part A or part B. Well, is 0 less than negative 2 or greater than or equal to negative 2? Oh, it's greater than. So we should use part B for that one. If I put 0 in for x, negative 2 times 0 is 0, minus 3 is negative 3. So f of 0 is negative 3. Okay, and if you looked at part B, 0, negative 3 is a point on that part of the table. F of 2. Again, we're using the f function, and we're plugging in 2. We just need to decide if it's part A or B. It's going to be part B because 2 is in the greater than or equal to negative 2's part. Negative 2 times 2 is negative 4, minus 3 is negative 7. The point 2, negative 7 was on our table there. Okay? All right, then they have us transition over to G. So that means we're using the G function. G of negative 3. Negative 3 is in part A because negative 3 is less than or equal to x, which is less than 0. We're plugging in 3, so we're going to be in part A. When you plug in negative 3, you get negative 1. Okay? G of 0. Well, 0 is in part B. So our y value is 3. And then G of 2. 2 is greater than 0, so we're in part C. If you plug in 2, you would get negative 2. Okay? All right, a couple other examples. I'm going to label these part A and part B. For part A, we're plugging in x values that are less than 0. So negative 3, negative 2, negative 1. I can put a 0, but I'm going to put a star next to it because the equal to is not on part A. If I plug in negative 3, negative 2 times negative 3 is negative 6. Minus 2 is negative 8. If I plug in a negative 2, I'll get negative 6. If I plug in a negative 1, I'll get negative 4. And if I plug in a 0, I'll get negative 2. I can plot those points. Negative 3, negative 8. No, notice that we're kind of off the screen here. Negative 2, negative 6. Negative 1, negative 4. And then 0, negative 2. But that needs to be a hollow dot because 0 was not included. I didn't have an equal to. Connect the dots, draw a line. For part B, we use x is greater than or equal to 0. So that means it starts at 0 and it keeps on going. 1, 2, etc. If I plug in a 0, 0 squared is 0. If I plug in a 1, 1 squared is 1. Plug in a 2, 2 squared is 4. So 0, 0, 1, 1, 2, 4. Now notice that should be kind of arced like a parabola because this is a quadratic equation, right? X squareds make parabolas. It's just that we didn't draw the whole parabola. We only drew the parabola on the right-hand side because they wanted when x is greater than or equal to 0. When x was less than 0, our graph needed to be this straight line, y equals 2x minus 2. Okay, another one with 3 parts. So part A here, x is less than 1, so I can only use numbers less than 1. So maybe negative 2, negative 1, 0, and 1. I'm going to put a star by 1 because it didn't have the equal to. Negative 2 plus 3 is 1. Negative 1 plus 3 is 2. 0 plus 3 is 3. 1 plus 3 is 4. And I can plot those points. But of course 1, 4 is a hollow dot. This one does have the whole line drawn with an arrow because it just said, hey, anything less than 1. Part B, the only number I can plug in is 1, and when you put in 1 for x, automatically a 2 came out for y. So 1, 2 is the point right there. And then for part C, they're telling me to use any x greater than 1. So I'm going to start at 1, but I'm going to put a star. It's going to have a hollow dot. 2, 3, etc. Okay? When I put in a 1, I'll have to work out square root of 1 minus 1. Well, 1 minus 1 is 0. Square root of 0 is 0. If I put in a 2, 2 minus 1 is 1. Square root of 1 is 1. If you're not sure how to do those, you could type those in. Square root of 1 minus 1, that was 0. Square root of 2 minus 1, that was 1. I'm going to skip 3 and 4, and I'm going to go to 5. Reason being, when I plug in 5, I'll have square root of 5 minus 1, and that's going to come out to be 2. It's just a nice, pretty whole number. So 1, 0 had a hollow dot, 2, 1 was solid, 5, 2 was solid, and notice when I connect those dots, it's that sideways kind of half U, because remember our square root function, that's what the square root function looks like. And the minus 1 shifted it 1 unit to the right. So that's, using transformations, we could figure out what that part looked like. Okay? All right, so now they've given us some new functions here. Here's a function f of x. They want us to find f of negative 1. So we're going to plug negative 1 into the f of x function, but which part? Are we going to use part A or part B? Well, negative 1 is less than 0, so we're going to use part A for that. And we plug in negative 1 squared is 1, plus 1 is 2. Okay? So basically I'm plugging in negative 1 for x, negative 1 squared, plus 1, that works out to be 2. When I plug in 5, well, which part should 5 go in? Is 5 less than 0? No, 5 is greater than 0. So we should use part B for this one. If I put in a 5, 5 minus 1 is 4. When I plug in a 0, I'm going to use part B because part B had the equal to 0. Plug in a 0, 0 minus 1 is negative 1. So those would be the values that would come out. Notice they've given us a graph over here for it. And when x is negative 1, the y value is 2, according to the graph. When x is 5, the y value is up here at 4. When x is 0, the y value is down here at negative 1. So since they gave us a graph, we could have used the graph, but you could also plug in the appropriate numbers into part A or part B. Okay, number 16, this is a h of x function, and it has 3 parts. Part A, part B, part C. When we plug in a 1, 1 is less than 2, so it should be part of part A here. 1 squared is 1, plus 3 is 4. If we plug in a 3, 3 is not less than 2, but it's between 2 and 4, so we're going to use part B for that one. Even though we're plugging in a 3, there's no x to put it in, so we just get the 7. When we plug in a 4, notice 4 is not greater than 4, it's equal to 4. So we're going to have to use part B again, and it comes out as 7. And then when we plug in a 5, 5 is greater than 4, so we'll use part C. 2 times 5 is 10, minus 1 is 9, so when you plug 5 into part C, you get a 9 to come out. And then there's one word problem. Excuse me. There are times when piecewise functions apply in word problems, so let's look at an example. A new job offer in sales promises a base salary of $3,000 a month, so that means you're guaranteed to make $3,000 as your monthly salary. Once the salesperson reaches $50,000 in total sales, he earns his base salary plus a 4.3 commission on all sales of $50,000 or more. Write a piecewise function defined as S of x to model the expected monthly salary as a function of the sales. Okay, so here's what happens. If you don't sell very much, okay, maybe not very much in sales happens, they're going to promise you that you're going to make $3,000. But if you sell a lot, if you sell more than $50,000 worth of items, they're going to give you your $3,000 plus commission. Okay? Commission means that you get a percentage of what you sell. So, they ring up the sales, the money goes in the cash register, and at the end of the month they go, oh, you sold this much? We're going to give you a portion of those sales for you to keep. Okay? And the portion they're giving you is 4.3% of however much you sell. So 4.3% as a decimal is the decimal 0.043. So they are going to multiply 0.043 times whatever you sell. We're going to call that X. Okay? Now, actually, you don't get that on everything you sell. You just get that on whatever you sold above $50,000. So, in other words, if you sold $60,000, you would get 4.3% of $10,000 because the first $50,000 they're not giving you commission on. They're only giving you commission on the part above it. So, however much you sold minus $50,000 is the part that they're going to pay you commission on. Okay? All right, and then I'm going to put a little semicolons here, and I got to talk about X. Well, if you sell less than $50,000, you're only going to get your $3,000. So I'm going to say X is less than $50,000. If you sell over $50,000, greater than or equal to $50,000, that's when you're going to switch over to equation B, and they're going to use this formula to figure out how much they're going to pay you. Okay, so that's a good word problem example using a piecewise function.